we present FaceUI, a novel strategy to assess mid-air face-centered spatial interfaces with off-the-shelf smartphones. FaceUI uses the smartphone's front-facing camera to track the phone's mid-air position relative to the user's face. This self-contained tracking mechanism opens up new opportunities that leveraged the empty mid-air space in front of the user to accommodate virtual windows, which the user can browse by moving the phone in the space in front of their face. We conducted 2 studies to explore the comfortable phone-to-face distance range for assessing virtual UIs in the in-ear space, and identify suitable viewing angles for browsing and inspecting content that reside in the in-ear space. We used this knowledge to design a FaceUI-based calendar application. We conducted a further study to evaluate users' performance in a calendar browsing task while comparing FaceUI with touch-based interface. In the first study, we began to explore the comfortable phone-to-face distance while assessing UIs in both horizontal and vertical directions relative to a user's face. Results from the study showed that neither distance nor direction was found to have significant effects on trial time. However, we observed increased trial time with items located in certain vertical locations than others. In the second study, we explored suitable viewing angles where users can comfortably assess on-screen items on smartphones. We used circle counting tasks in this study, where participants were required to count the number of circles presented in 2 windows located at different angles in the left, right, up, or down regions. Results showed that assessing content position in the upper region is slower than any other region. Also, participants' performance degraded significantly at the highest angle in each region. We used this knowledge to design a FaceUI-based calendar application. In a third user study, we evaluated users' performance in a calendar browsing task while comparing FaceUI-based calendars with a touch-based calendar interface. With the traditional touch interface, the task involves selecting a date and inspecting several events on that date. This inspection requires users to switch back and forth between a list of events and their detailed view. With FaceUI, we leveraged the empty mid-air space in front of the user to accommodate detailed view. A user can assess the detail on the events on the detailed view by simply moving their phone in mid-air space rather than touching on the screen. Our results showed that FaceUI approach can offer considerable advantages compared to traditional touch-based interfaces. Here we show 2 applications to demonstrate how face-centered spatial user interface can be used in an off-the-shelf smartphone. FaceUI-based image browsing app offloads a set of images on the in-air space in front of users into a 5x3 grid. Users can browse them by moving the device along horizontal and vertical directions. We designed another app to browse message history, where FaceUI can be used to assess previous or new messages in the Messenger app by moving the phone upwards or downwards in front of the user's face. We show that FaceUI is a promising solution that leverages the empty mid-air space in front of users for browsing on-device content with off-the-shelf smartphones.